Here we are, week 6, part 1. Part 2, most people find using Poisson Excel difficult because of that whole rule that was the same for binomials, where if it's a more than, you've got to have that first number in the parentheses be the opposite of what you're really looking for. Because of that, that's going to be Thursday's lecture. You don't want to miss it, because there's if you look on the homework this week, you have 2 assignments like usual. You have the written assignment, you have the Excel assignment. But it's the Excel assignment. Did I open it? No, I didn't. Yeah. Oh, I didn't open it. It's the Excel assignment that you have about 5 or 6 Excel Poisson equations you have to write to answer the questions. So that's all about Thursday, and I don't want you to miss that. But let's get to let's go back. This is the written assignment we're going to talk about today. But before that, here again are the materials for this week. The quiz, which is 2 days, 1 week, what is that, 9 days from today, that quiz, if you say to yourself, what should I have ready to go from Canvas? What should I study? What should I look over and ready to go? Just go to these instructions, and there's what you should have. Which PowerPoints you should have, which book pages you should have ready, and any of those things I posted on Canvas will be listed there. All right, so the written assignment. Did I open it? Here it is. Well, it says answer, but it's not the answer. So when you guys open that up, ignore the word answer at the top. So the first, second, and third question are all about Poisson's manual, how to do it manually, which we're going to talk about, but I want to introduce you to it right now. This is it. The equation is you take the mean to the exponent of the number you're being asked the probability of. Let me repeat that. The mean, which is given, to the exponent of the number you're being asked the probability of, times E. E's in stone. It's on our calculator. All you gotta do is hit the E key. You don't even have to come up with that number. 2.71828, something like that. Let me just put it on here. 2.718281828. That's how I can remember because it repeats. 2.71828. Going 4 digits. 2.71883. I guess if we're rounding correctly, but go 2.71828 if you can. There's E to the exponent of the given mean, negative. So we're multiplying the mean to the exponent of the number being asked the probability of, times E to the exponent of the mean, negative. The same mean you put back here.
But make it a negative?
But you make it negative. You gotta make that mean negative. So it's a negative exponent. Over the number being asked the probability of, factorial. Exclamation point. Factorial. There's the manual equation. You're really only got to find 2 numbers out of the stories. The mean and the number being asked about. Because E is given. E is 2.71828. It always is. That's in stone in math.
What is it?
2.71828. 2.71828. There it is right there. 2.718281828.
How can we find it in the custom?
Look for the E, the key that mentions E. Like, see how this one has a little E right there? Right there's an E. Hit it again. It's the same answer. Here's pi right next to it, 3.14. There's E, 2.71828. You gotta find it. Could be a second, could be on top, could be. But worst scenario is, you know that the computer calculator has it. That's the worst scenario. Or just write down 2.71828. So that's it. You just got to find 2 numbers. The number you're being asked about, the mean. Here's the tough part about today. The story sometimes doesn't give you the correct mean. It's all because Poissons are the number of occurrences over a specified interval of time or space. Because Poisson is the number of occurrences, how many over an interval of time, how many in the next hour, how many in the next half hour, or space, how many in the next mile, how many in the next 10 linear feet. Interval of time and space. So it's always asking you how many per interval. That's how you recognize Poisson. Now, Thursday morning, when you get here, I want to start the lecture off by putting 3 problems up there on the board, on the screen. I'm going to put a normal probability, a binomial probability, and a Poisson probability. And I want you to be able to recognize the Poisson out of those. Binomial always talks about, hey, we're going to take a random sample of this many, how many out of this many will do this? Remember that? Normal always says, here's the mean and the standard deviation. That's how you know it's normal, standard deviation. How do you know it's binomial? We have a random sample of this many, and we're trying to find the probability of this many out of that many. How do you recognize Poisson? It's asking you for the probability of this many occurrences over a period of time or space, or a length of space. That's how you recognize it. All right, I just want you to look at number 1. A highway study finds on average there are 4 potholes every 8 miles of a particular highway. Using the Poisson equation from Chapter 5 PowerPoint, show detailed work to calculate the probability of 3 potholes in an 8-mile section of highway. Now look at the intervals. First of all, you recognize this is Poisson because of these words. Calculate the probability of 3 potholes, number of occurrences, over during an interval. And it says 3 potholes in an 8-mile section. Interval of space, 8 miles. How many per 8 miles? That's how you recognize this Poisson. That's when we use Poisson, when there's discrete counts involved. Hey, there were 5 cars that went by in the last 20 minutes. 5 cars per 20 minutes. So it's how many, it's discrete numbers, 1, 2, 3, 4, no numbers between, per an interval. Now I want to bring to your attention real quick what would happen if I change this question. All right? The part B says, hey, use the same work above, but this time calculate the probability of 2 potholes in a 4-mile section. Now here's the deal. Let's go back to the first question. The first question said there are usually average mean of 4 potholes every 8 miles. It's asking you the probability of 3 potholes per 8 miles. It's asking you the probability of 3 potholes. There's what you're being asked about. And it says on average there are 4 potholes there and there. -4, 4, -4. Get it? All right, we're going to come back to this. I just wanted to introduce you to it so you have an idea. Real quick, before we leave it, do you think you understand about number 2? Did you notice the interval is not the same as number 1? It's not 8 miles. It's 4 miles. This interval, what percent of this interval is it compared to the previous interval? Half of it. So you have to know you never change the number you're being asked the probability of. That number's in stone. That's the number you're going to find the probability of. But the mean that you're given, you might have to adjust based on the interval the question's about. Let me make sure you get me here. Number 2 is asking about how many? 2 potholes per 4 miles. But the mean in the previous question were 4 potholes per 8 miles. You are not going to use a 4 for the mean here and here on part 2. You must adjust that mean based on the interval being asked about. But you don't change that. How many potholes is asking about the probability of 2 potholes per 4 miles? That 2 is 2. Where it says number being asked about, that's a 2. You don't change that. But the mean is no longer 4 because the mean was based on an 8-mile stretch. The problems of the question 2 is asking about a 4-mile stretch. You must convert the mean. Now, forget that for a second because I'm not doing your homework. We gotta get that off there. Instead, we're gonna find an example problem, which is right, hang on, I gotta switch this to over here. Oh, no, not that example problem. Wait, hang on, I forgot. I'm switching it to here. This example problem. You ready? Here's an example. This question would say, what's the probability that there'll be 5 knotholes in 14 linear feet of pine board? Okay, what did I say, 5 knotholes? 5 knotholes is the occurrences, number of occurrences, 5 knotholes. The interval of time or space is the 14 linear feet of pine board. That's the interval, and it's 14 linear feet. Let me give you another example of a Poisson question. what's the probability there'll be 5 vehicles arriving at this toll booth in the next hour? The occurrences is the 5, what did I say, cars? The 5 vehicles pulling up to the booth. That 5 is the number of occurrences. The hour is the interval of time or space. What's the probability of 5 occurrences over an hour time? Those are the what you're looking for. Okay, now we gotta compare it to the mean over the same interval, which happens to be an hour of time. Everybody see how to recognize Poisson questions. Go ahead.
What would be the mean though?
Well, we're just recognizing when you have Poisson. Here's the deal. Whether it's Poisson or exponential or some other problem, the mean can be described in ways that will deceive what you think you're reading. You cannot rely on how the mean is described to determine what kind of problem you have, unless it's normal, because normal will also say what the mean standard deviation is. But when it comes to exponential, when it comes to Poisson, you cannot rely on the mean description, because the mean description is not giving away what kind of problem is. It's the description of what the probability you are supposed to calculate. That's what gives away what kind of problem this is. These 2 sentences I'm going to put in the form of a probability question so that you can recognize you're looking at Poisson. The first one again is, what's the probability there's 5 knot holes in the next 14 linear feet of pine board? That question is what causes you to say, oh, this is Poisson. It's asking me about a number of occurrence over an interval. What's the probability there's 5 vehicles arriving at the toll booth in the next 1 hour? There's the question, and that's how you recognize this is a Poisson. It's the number of occurrences, cars pulling up to the toll booth over an interval, 1 hour. This is Poisson. The amount of points you'll lose on the next quiz and on the final exam for not recognizing the right problem is where people screw their grade up. That's why I'm emphasizing this the most. And when I put up these 3 problems in the morning on Thursday, it's all about you preparing for the final exam, because you have 6 or 7 different types of problems, and you got to recognize which one you're reading. Because if you use the wrong equation because you didn't recognize the right problem, the amount of points you lose on that one problem will probably throw your whole grade off. So it's all about recognizing what kind of problem.
For the next quiz, would you put a problem like the one that we're gonna do on Thursday, where you give us the 3 different ones and you tell us to choose which one's the right one?
Yes, the problem you're gonna read, as a matter of fact, the homework problem is just like a quiz problem or a final exam problem. They're gonna read just like that, and then the 3 I have up there will be just like quiz problems too. But one will be, like you're saying, one will be normal, one will be binomial, one will be what we just learned, Poisson. It's all about on Thursday morning, you being ready to recognize which one's Poisson. The first one, the second one, or the third
On
one?
the next quiz?
No, I'm just putting that up on Thursday morning. I'm preparing you for Thursday morning.
Oh, okay.
Thursday morning, I want you to be able to tell the difference between these equations, because that's where most of the points are lost, by not recognizing what kind of question you're reading. I want to avoid that this semester. I don't want you guys to lose points because you're reading the wrong question. I won't, lose points because your math was off or something. Those are so few points of loss, but doing the wrong equation, you're losing way too many points. You're just taking your grade and throwing it out the window. So that's the most important thing to focus on, is recognizing these questions. So let's go to this one. Hang on, here we go. Whoop, hang on. Patients arrive at an emergency room, Mercy Hospital, at an average of 6 per hour on weekend evenings. 6 per hour. 6 is the occurrences of patients arriving, and the interval is per hour. If I needed to convert this mean to a half hour, how many would on average arrive in a half hour?
3.
3, because it's 6 per hour. A half hour is half of an hour, so you would change the mean from 6 to 3. Get it? All right. If the mean is 6 per hour arriving at this emergency room, but the question's about a 15-minute interval. Think about it, take your time. 15-minute interval, what's the mean in that case?
It's a quarter of whatever.
It's a quarter of whatever, what is it? Right now it's 6, what's a quarter of 6? What's 6 divided by 4? 1.5. 1.5 would be the mean. So the point I'm trying to make is, whatever the given mean is to you, you then got to read what the probability is being asked about. That number you don't change. What's being asked about doesn't change, but you got to match the mean to the interval of the question. So right now the mean being given to us is 6 per hour, but the question could be about a half hour, the question could be about 15 minutes, the question could be about 10 minutes. What would be our mean if the question's about 10 minutes? Our mean is 6 per hour, but the question's about 10 minutes. What do we have to convert the mean to? From 6 to what?
1.
1. Because 10 minutes is 1/6 of an hour. So 1/6 of 6 would be 1.
For equations. Come on, let's get you.
All right. All right, so now we have the mean. These questions for Poisson almost always start by giving the mean. Now here's the question. You ready? Now you don't know whether you need to convert the mean yet. Let me ask the question. What's the probability 5 arrivals in 60 minutes? Is the interval the same as the mean? Are the two intervals the same?
Yeah.
Because the mean's in 60 minutes, the question's in 60 minutes. So my question to you is, what number goes right in these two spots? The number being asked the probability of what number?
65.
5. The number, the interval is 60 minutes, which is an hour, but the question's about 5 arrivals. What being asked about is the number of occurrences. We're checking the interval, the 60 minutes and the hour, to see if we need to convert the mean or not. You just got done telling me that these are the same interval, and we're putting a 5 here and here. So what number then goes where it says mean and negative mean there? What number?
6.
What's the mean?
6.
6, because we didn't have to convert it. So that's the only two numbers you mean. We got 6 to the power of 5 times e to the power of -6, all over 5 factorial. That's it. That's how easy these are. It is harder for you to recognize you're reading a Poisson than to plug the numbers in once you get this. You get it? You guys got to get it though. I want to get you to where you're converting one. Go.
Could you do that example on the board?
Yeah, sure. Again, set it up, you mean?
Yeah.
Okay, you ready? The mean was 6 to the power of 5 times e, I got 2.71828, I can't remember, to -6 to the power of -6 over 5 factorial. There's the setup. This is where most of the points are. On that quiz, I'm looking for that setup right there. That's where most of the points are, just like last quiz. And you notice that as long as you had it set up right, you did pretty well on that problem. That maybe your math was off, or maybe you forgot to give the final answer or something. But that setup, you had it right. There's where most points are, here and then here.
So let's say you said 5 in 15 minutes. So you divide 6 by 4.
If I said 5 in 15 minutes, this is still a 5 here and here, but this 6, because it's 15 minutes, is no longer 6. The 6 here and the -6 there becomes what?
1.25.
Because 15 minutes is a fourth of an hour. You gotta take 6 into a fourth, so this ends up being 1.5 here and -1.5 here. If it truly said. Now here's one you're gonna have to convert. Ready? What's the probability there's 4 arrivals in 30 minutes? So help me out. 4 arrivals in 30 minutes. I'm looking for 2 numbers, the mean and the question. What's the question asking about? How many?
4.
4. That you have to use. So I'm gonna do this right here. Here's the 4 exponent. Here's the 4 factorial. There's that part. Now, what mean would I use?
3.
Why 3?
Because you have to divide by 2.
Everybody get it? The question's about 30 minutes, but the mean's being given to us as a whole hour. Oh, I thought you already asked yours. And the mean's being given to us as a whole hour, but because the question's 30 minutes, I can't use the whole mean. I gotta split it in half because the time is split in half. So our mean is gonna be 3 to the power of 4 times e to the power of -3.
Okay, so
There it is. Hit me with your question and then I'll come back.
Yeah, I was gonna ask, how did, like, you see how you got over there 5? I get that, but how'd you get the 6?
The 6 is given to us originally. It said 6 per hour in the description up here. But I converted the 6 to 1.5 because she changed it to 15 minutes. And 15 minutes is a fourth of an hour, so a fourth of 6 is 1.5. You gotta convert the mean to based on the interval. Go ahead and ask your question now.
same thing with the -3.
Okay, now let's talk about this one over here with the 3. Because the second question said 4 occurrences, arrivals, in 30 minutes, the interval is no longer an hour. The interval is half of an hour, so I had to use half the mean. So I had to convert 6 in half to 3 and -3 because the time was half. You still look confused.
A little bit.
Okay, let's do another one. You ready? You ready? What's the probability of, let me see, I'm making this up on the fly here. Hang on, let me think. What's the probability there'll be 3 arrivals, and I already gave away everything I could compute in my head on 60 minutes, so I'm just gonna say 10 minutes again. 10 minutes, and now look at this, I'm changing this to 2 arrivals in 10 minutes. Set this up for me, set this up, ready? I want you to start 2 arrivals in 10 minutes, the mean is 6 in hour, the mean is 6 per hour. The question's about 2 in 10 minutes. help me set it up. I got e to the power of something. I got mean.
We did the two, right?
2.
Okay, the 2 is the number being asked about. So I'm putting the 2 in exponent here and the 2 factorial there, because that doesn't change. But what's the mean?
Five.
Just let them do it. What's the mean?
So it was originally.
Think about 10 minutes. 10 minutes is what portion of an hour? Hang on, you gotta wait. Voiceless. What?
I don't have the.
Help them then. Go ahead, help them. We're not gonna be able to hear you. Oh, you're giving me signal? Okay, that is not gonna show up on video. 1, is that what that means? Okay, 1. That's right, because 10 minutes is a sixth of an hour. A sixth of 6 is 1. So 1, the mean turns into 1 to the power of 2, e to the power of negative 1. You've gotta convert the mean to match the interval of the question.
Okay, but like the confirmation, like, I don't get it. How do you convert like?
Well, you've got to say to yourself, if the mean's given it for a whole hour, what portion of that hour? You ready? Ready? Here's one more. I got a new one. Here we go. I'm so happy I thought of a new one. What's the probability of 6 in the next 2 hours? 6 in the next 2 hours. Don't let me fool you. Hang on, wait. Let's see.
Wait, what's the?
Come on now. This is 6 in 2 hours. Well, probability of 6 in 2 hours. The mean is 6 per hour still. Nothing's changed there. But the question's about 6 in 2 hours. Do I change this number 6 in 2 hours at all? What's the probability of 6 in 2 hours? Do I change that?
No.
No. So you know this is going to be something to the power of 6 over 6 factorial. 64. What does that mean?
The minutes?
Yeah. Took the drive today. It wasn't bad. All right. So we have 6 factorial, 6 here. We know this is e. What's the mean? You let these two help me here. The mean, don't forget now, the interval is no longer 6 an hour. The question's about 2 hours. So what would that mean be? I know you guys know. Hang on. They're all anxious to tell. You guys, think about it. What is 2 hours compared to an hour? What is that?
So it's another 60 minutes.
9.
That's right. It's another 60 minutes. It's 2 times. So what would be the mean?
120?
No. That would be the time. The mean is 6 per hour. What did you do to that
Oh,
hour?
12.
There you go. You had to double the time, so you got to double the mean. So this ends up being 12 to the power of 6 and e to the negative 12. You got it. You guys, you get it? Did you see it?
Yeah.
Because the time of the question doubles, you got to take the mean and double it. Everybody see that? Is that what you guys would have said? Everybody back here? You would have? Okay. So you're getting it. All right, we got to get to the boring stuff. This was supposed to be the end of the lecture, not the beginning. Jeez, I don't know how this even happened. I can't even look at my notes now. I got to figure out where I'm at. Oh, here we go. We got to get to the good stuff. The counting. All right, what is this? This is the counting rule for multi-step. This is where I usually tell this whole story about how this is done in real life, because I had to experience it. I was the business manager for a large college, a private college, I think the largest private college in Michigan, Baker College. And I was the business manager, and a lot of my duties had to do with investing money, because we had a lot of excess money. We had millions of dollars. And so, because we were a nonprofit institution, we had a rule, an investing rule, that we couldn't take too much risk. Matter of fact, the investments I focused on were all insured investments. Insured, just like if you were to take money to a savings account or a credit union at a bank or a savings account at a credit union, yours is insured by the federal government up to $250,000 per account holder, per account. So, but if something happens to that bank or that credit union, any money you have in there over and above $250,000 is pretty much lost, because that credit union had mismanagement or whatever caused it to go out of business. So that's the same with investing. I used to invest with jumbo CDs. Back then, you have to do 100,000, and I would be looking for 30-day CDs. But when it comes to corporations who are willing to take risks, they have all the upper management involved. Maybe not just the business manager like myself, but all of upper management. And you sit at a table at these executive meetings, and you start talking about things like this. Hey, we got this extra money, and I have these 2 investment opportunities. Here's what the outcome is if we lend this money to these 2 companies. They're either going to pay us back 10,000, Markley Oil, this is in thousands. If we do Markley Oil, they're either going to be paying us back after 3 months, 10,000 profit, 5,000 profit, or just give us back our money, break even, or we could lose $20,000 of our money. There's the 4 possibilities that could happen if we go with Markley Oil. Now, at a nonprofit organization, like I was at, we would never do this. We would never take an investment that has the possibility of losing $20,000 or any money at all. but corporations do this all the time. The other investment called Collins Mining, we're gonna put money there for 3 months, and there's two possible outcomes. Either they're gonna pay us back an extra $8,000, or we're gonna lose $2,000. All right, so here's the deal. We're trying to figure out how many different outcomes could happen with these two events at the same time, the same 3-month period. And this is called a multi-step calculation. And it's about to figure out how many different outcomes there are. You have to multiply the number of outcomes of one event times the number of outcomes of the other. So based on what I just told you, how many outcomes do you see possible with these two? How many events are there with Markley Oil? How many possible outcomes?
4.
4. How many outcomes with Collins Mining?
2.
How many outcomes with them together?
6.
6.
Don't add them, multiply them.
8.
8. Here they are. Markley Oil is either gain 10, gain 5, break even, or lose 20. Collins Mining either make 8 or lose 2. Make 8, lose 2. Make 8, lose 2. Make 8, lose 2. 8 possibilities. There they are. Both possibilities are going to take place at the same time, so here are the real 8 outcomes. Make 18,000, make 8,000, make 13, make 3, make 8, lose 2, lose 12, lose 22. My question for you is, out of this 8, how many of them could we lose money? How many?
2. 3.
3. The bottom 3. We could lose 2,000, lose 12,000, or lose 22. So 3 out of the 8 we could lose money, which means 5 out of the 8 we could make money. Okay. Now this is what comes up in real life. What's the probability of making money? What's the probability of losing money? This is the tough part. There's several ways to apply probabilities to this, and here are 3 of them. The classical method, the relative frequency method, and what's called the subjective method. The subjective method is actually kind of the most common. And subjective means it's a human's viewpoint, maybe an expert's viewpoint, or if they have expertise in whatever it is that's being discussed and assigning those probabilities. Whatever the probabilities are and however we assign them, we know that if we do this, one of these 8 outcomes are going to happen. And so, since one of those are going to happen, whatever probabilities we assign to these 8 outcomes must add up to 100%, because one's going to happen. Something's going to happen if we do this. All right, they got to add up to 100%. Let's start with the classical method. To remember the classical method, I always talk about a die. Think about a die. You're in Vegas, so you know the die weighs perfect. You know it's cut perfect. So every side has exactly the same chance. So I roll that die, and I'm curious as to what the % chance is of me rolling a 5 with that die. What's the chance? 1 in what? 1 in 6. Because each side of the die has the exact same probability as the other. 1 divided by 6. I'm going to turn it into a percentage. Each one has exactly the same probability. So that's called the classical method. You give the same probability to each possible outcome.
16.
Each outcome has about 16.67% chance, rounding. 16.67% chance of rolling a 5. 16.67% chance of rolling a 6, a 4, a 2, a 1. If we use the classical method on these decisions, what % chance is there of this one happening? This top one, making 10,000 off Markley, and at the same time making 8,000 off Collins at the end of these 3 months. Using the classical method, what's the % chance? Anybody got it?
1 over 8.
1 over 8 is the perfect, and I don't know what it equals, but that's it, because there was 8 of them. Is that what it is? 12.5%, 0.125 on the nose. That's the classical method. You probably have a question coming up in your future that says, hey, what would be the % chance of this happening if you use the classical method? You quickly start looking up the classical method to try to refresh your memory what it means, right? And you then show me your calculation, 1 divided by 8, 1 divided by 6. Whatever you're gonna do to show me what the % chance is, using the classical method. Everybody get it? It's 1 divided by however many outcomes are available. A die has 6, this has 8. 1 divided by 8, or 1 divided by 6, or whatever the number of outcomes. Classical's history now, we got it. All right. Subjective or relative? First of all, let's confirm how many outcomes there are. 8, 4 times 2, there's that. Let's confirm what the 8 outcomes are. There they are, 10 and 8, 10 and -2, 5 and 8, 5 and -2. And there they are making 18,000, all the way down to losing 22,000. Losing 22,000. This is a big risk when you think about it. Okay? Again, I'm gonna keep going with this. Relative frequency method. We have actually learned the relative frequency method already. If we had historical data, we would count how many times each outcome happens. I would count how many times were Markley Oil able to pay a 10,000 profit? How many times were they able to pay a 5,000 profit? How many times did they break even? How many times did the investor lose 20,000? We would look at historical and count how many times and divide it by the total count. Remember when we did that with, is this on this PowerPoint? Let's see if this is on this PowerPoint. Remember when we did that? Here we go. Polishers. Here's an example of relative frequency right here. We're thinking about taking a polisher and taking it out of rotation. How many do we have now? Probability, the number of polishers will be rented each day, our records show, for the last 40 days. So we looked at the last 40 days, how many polishers got rented, and we counted. Out of the last 40 days, 4 of them, we never rented a polisher. We're a tool rental place, and no one rented the polisher. 6 times, 1 polisher got rented. 18 times, 2 got rented. 10 times, 3 got rented. And twice out of the last 40 days, all 4 that we have here got rented. I want to send 1 to get fixed. We're only going to have 3 left. My question for you is, well, hang on. If I said we only have 3 left, how many out of 40 days could we end up having to turn a customer away? Let me ask that question again. You heard it, I think. Someone heard it. Here we go. I'm thinking about taking a polisher out of there. We're only going to leave us with 3 polishers. How many days out of the last 40 would we have, if we only had 3 polishers, would we have had to turn a customer away? 2 days. Because there was only 2 days out of the last 40 where we rented all 4 polishers. But I want you to turn it into relative frequency. So you got to take each number and divide by the total, which is 40.
10 days.
4 divided by 40. 6 divided by 40, 18 divided by 40, 10 divided by 40, and 2 divided by 40. There it is. Now I'm going to ask the question again. I'm thinking about sending a polisher to be repaired. That will leave us with 3 polishers. What % chances there we're going to have to turn a customer away tomorrow because we only have 3 polishers?
5%.
There it is, 0.05, 5% chance. Because the odds, based on the last 40 days of us having a 4th polisher needed to be rented, only 2 of the last 40 days, which is a 5% chance. Using historical information and dividing by the total number that we went back allows us to create a relative frequency table, which you did in your homework you just handed in today. That's relative frequency. So we would do the same here by counting how many days this happened, this happened, this happened, and we could apply relative frequency. But, let's go back. That's not the case. That is not the case here. We don't have history on these 2 companies. We don't know how many days they lost 20,000 or how many days they gave back 5,000 profit to the investor or whoever loaned them the money or invested in them. We don't know that. So we instead, and this is how it works in real world, I had a committee in real world. Let's say I'm trying to decide whether to do this investment, and I formed a committee with some of the other executives at the company I was at. And we started talking about these 2 companies and what we think our chances are of making 10,000, making 5, breaking even, or losing 20 on that first company. And our % chances of the other one too. All through discussion and what we may have spent a whole month, everybody researching this to decide. It's now time to make the decision. What % chance do you think it is of that happening or that happening? We would debate it. But we would make sure when we apply percentages to these that they added to 100% because we know one of these are going to happen. That's called subjective. Subjective means we pulled it out of the air. Boom. Through debate, through expert conversation, through looking up information, however it happened, it was subjective. There was no math involved, no real math. We're pulling it out of the air. Let's pretend these are the subjective probabilities of all 8 decisions. There they are. Are you ready? Now, this is all about you being able to read these probabilities. For example, what's the probability that we're going to lose money? What's the probability we'll lose money? Not 2,
20%.
not 3. What probability?
20%.
20%.
Oh, you added the percent.
You gotta add all three of them that show we're losing money, so you had to add the 12% plus the 2 plus the 6. What's the percent chance that we're gonna make some money?
80%.
The opposite. You would add up all the gains, the 5 above it. The 10 plus the 26 plus the 16 plus the 8 plus the 20. Yes?
So you would add the net gain?
No, not the net gain itself. You're adding the probability of that gain to answer that question. What's the probability we'll make gain? That we're gonna have a gain. And so you would add up those probabilities for the gains. Don't mix it up with how much we're gonna make. That's not being asked about.
Right.
This is all about what's the probability of this happening or that happening. Let me ask you another question. Ready? What's the probability, based on our subjective probabilities, that the outcome will at least have the first company making money? Let me repeat what I said. What's the probability that at least the first company, Markley Oil, will be making money?
20%.
40%.
I hear 20, I hear 40.
40.
I'm looking at wherever the first number has a gain, which I think is just the top 4. So 20 plus 8 plus 16 plus 26 equals what? 40, 50, hang on, 40, 50, 64%? No, there's a 6 there. Wait, 20, 40, 50, 62, 70%. Does that sound right? I added up all the ones that had the first company making money. You gotta hear the words of the question, look at this, look at the percentages and decide which ones to you. And if this were a test, a quiz on, then you gotta show me which numbers you're adding together. Not just give me the answer, show me which numbers you're using. So you would have to show me you're using the 20% plus the 8% plus the 16 plus the 26, those 4.
Why not the 10?
Because the first company's only breaking even on that one. The question said the probability the first company at least makes money. I'm gonna say it a different way, ready? Ready? Here's what I want this time. I want you to tell me which numbers you're using, which percentages off of there you're gonna use to answer this question. What's the probability the second company, Collins Mining, makes money? Give me the numbers. Point 20 plus point
16.
8, what is it, 16?
16.
16 plus point 10 plus point 02 plus,
That's it.
that's it. There's only 4 of them that the second company's making money. And you grab those probabilities off the 4 that the second company's making money. This is how you read this. You're getting it. All right, good. I think we're gonna go deeper into this, much deeper into this next week. Or is it the week after the quiz? I can't remember. One of those 2 weeks, we're going much deeper into this. We're gonna be learning, might as well bring them up to you. We're gonna be learning about the probability of an event, the complement of an event, the union of events, the intersection of events, mutually exclusive events, and then more importantly, hang on, let me get to the addition law. Hang on, the conditional probability. This is where I start to lose people right here, but we're gonna learn this in a week or 2 after the quiz. And multiplication law and independent events. This is where I lose everyone, right there. But we'll go over it in detail in a couple weeks. It's not going to be on this quiz, on this next quiz. It's going to be on the 3rd quiz.
How'd you get those probabilities?
Which probability? These right here?
Yeah.
I took them off that list. Let me put them back up here.
Yeah, but how'd they calculate that?
Oh yeah, don't forget, these probabilities are subjective. We went, this was the 3rd way remember I said, there's the classical way to assign it, there's the relative frequency, but subjective, we pulled these out of the air through debate at meetings. That's where those came from.
We'll never have to find.
Well, you can't look those up. Those, if they're subjective probabilities, they're being given to you. Those, that 20%, that 8%, that 16, that'll be given to you if they're subjective probabilities, because there's no way for you to get them. There's no way for, I'd be asking you to make them up.
They're given to you.
Yeah,
Probability.
but for classical, if I ask you to do classical, you gotta know to divide that there's 8 of them, 1 divided by 8 for each one. But if it's subjective, I'm giving you those probabilities. And let me give you a hint right now. I'm giving you these probabilities.
How come they use point 26?
Because it didn't have the second company making money. The question says, what's the probability the second company makes money? So you have to go with the 8s, all the 8s, and skip the negative 2s.
Like the question.
Get it?
The red assignment.
All right. Where are we at? How are we doing on time?
9 minutes left.
Wait, we only got like 7 minutes? That's all we got left? We gotta do combination permutations, and we gotta Excel. Combinations, permutations. We'll put off Excel till Thursday, depending on how we're doing here. But right now, with combinations and permutations, let me get you to that. Okay, here's a combination. formula. Look at how I'm describing it here. The larger number factorial, this is, here it shows you as a large N, and your book it uses different variables, actually. Over the larger number minus the smallest number factorial, parentheses are the subtraction, then the factorial on the outside, times the smaller number factorial. There it's a big N and a little n, but I'm using words. Let me repeat it. The larger number factorial is the numerator. The denominator is the larger number minus the smallest number, parentheses, factorial, times the smaller number factorial. And then that gets divided into the numerator. That is combination. Permutations are almost just like combination. I'm going to describe each, but permutations are almost just like combinations, except it leaves off part of the denominator. You don't use that part of the denominator. Here it is here. The larger number factorial over the large number minus the small number, parentheses, factorial. That one little part gets left out of the denominator for permutations. Now, how do you tell the difference between combination and permutation? Are you ready? Yeah, remember. If it's a permutation, the question will say something about how the order of selection matters, that it's important in some way. If it's a combination, the selection of order doesn't matter. Now, I want to get to an example so this all makes sense. Oh, come on. Here, right here. You ready? This Little League coach recruits 3 more players and now has backup players in case someone gets injured of a total of 12 players. So there's 12 players, but there's only 9 positions for players to play. So the coach has to select 9 players out of the 12, and the question is going to say, you know, how many different combinations of 9 players can be selected out of 12? And order doesn't matter, meaning, hey, when I select the first player, go anywhere out there. Pick one of those 9 positions. I don't care. I'm not specifically picking the first player as a pitcher. I'm not specifically picking the second player as first baseman. I'm not doing that. Order doesn't matter. Go play any spot you want. But I need to pick 9 players out of 12. How many different combinations could I have? So here, this would have been 12 factorial, which by the way, I did for you, if you want to know. Hang on, let me see. You ready? The numerator is 479,001,600. 479, 001, 600. There is 12 factorial. Now, the denominator, since order doesn't matter, we're picking 9 players. 12 minus 9. So here we go. This is going to be 12 minus 9 factorial. So that's 3 factorial, and 3 factorial equals 6. There's that one. The other one now is the small number, which is, what's the small? 9 players. 9 factorial. Oh my God, we gotta multiply that 6 times 9 factorial. And 9 factorial equals 362,880. If I take 479,001,600 and divide it by 6 times 362,880, I will get, let me go to the next page. This is how many different ways, where is it? Right there. That you can select 9 players out of 12, right there. 9 players out of 12 when order doesn't matter. Just picking any old 9 players. 3 are on the bench. Now a different 3 are on the bench. And a different 3, a couple of them are different. That's how many different ways. 220, go.
Where'd you get that number?
Where did I get what?
The 479. No.
This right here?
12
this is
factorial.
12 factorial. There you go. I should put that up there. Because it's 12 players we could choose from.
So like on the quiz, can we just show the factorial and use our calculator?
I want to see it set up. On the quiz, I want to see that you got 12 factorial over 12 minus 9 factorial times, what is this one? I forgot.
9.
3 factorial? No, this is, what is this?
9
Oh yeah, 9 factorial times 9 factorial. That setup I want to see. There's where most of the points are right there. Then show me at least 1 or 2 steps of math involved.
So we don't have to do.
So, sorry, say yours again.
That's a permutation.
No, that's a combination. Combination.
So we don't have to show like 12 times 11 times
No, you don't show that. You just gotta show me the result. Once I put 12 factorial here, then my next step could be 479,001,600. That would be, I know that you just did the factorial. You don't have to show the 12 times 11 times 10 times 9. Okay. Yeah, you do have to solve, yeah, but, you know, there's the solution right there. Okay, now we gotta do a permutation, and then we gotta, we'll say this, it's 10:42, we don't even have time for a permutation. So on Thursday, we pick up at permutation, we gotta do the 2 cells we didn't get done, and that's where we're gonna pick up. If you came in late, I got something to hand back to you, please pick this up on your way out. I will see you on Thursday. Anybody forget to sign in, go sign in.